Well, now I just hit the record button and it's already freezing up on me. But it seems okay now. So
Yeah.
let's turn on Audacity. Okay, I'm
Okay.
going to start recording in Audacity.
Well, you got to do our test.
All right, we got to do our test. So hold on a second. Let me be able to. Okay. Eeny, meeny, miny, mo.
Testing on the radio.
Eeny, meeny, miny, mo.
Testing on the radio.
Eeny, meeny, miny, mo.
Testing on the radio.
All right, Pete Giuliano, here we are. It is Wednesday, the 13th of October, 2021, and that makes this
233. Crank it in, Ralph, and
two,
crank it in, Robert.
two,
233.
233. I'm going to minimize my screen here so that I think we can see that we can see you now, Pete. Holy cow, this is just fantastic. We're recording here. Anyway, 233. Crank it in, Ralph. And who was the kid? Who was the kid that was listening?
Robert.
Was it Robert? Crank it in, Robert too. All right, Pete. Lots of stuff to report. It's been a while, but we're glad to be back on the SolderSmoke fiber optic cable. First, after a long time, travelogue to report. We did some traveling. We were up in Massachusetts, specifically on Cape Cod. We went up. We had friends let us use their beach house near Plymouth, and my son is in Boston, so we combined it with a trip to visit him and to go to the beach. And we went up to Cape Cod, and we started out in Plymouth. From Plymouth, you're looking out across Cape Cod Bay, the whole bay out there in the hook, and you could see off in the distance the lights of the town that's at the very end of the Cape Cod Peninsula called Provincetown. It was kind of cool because it looks like it's about a 20-mile shot across the water. You're up a little bit off sea level, they're up a little bit off sea level, so at night you can see the lights. And I operated a little QRP station. I took the SST with me and ran the SST from Cape Cod and made one contact. It wasn't, but it was a German contact, Pete, and it was CW, and so that was fun. And then when we rode out to out onto the peninsula there, we stopped off at the Marconi site out there on Cape Cod, where he had one of his original transmitters to go transatlantic. So that was pretty cool. But speaking of transatlantic, Pete, I think you have to explain to our listeners and viewers why this morning you are wearing a bow tie.
Yes. Okay. So this all started with the GQRP virtual convention, where I was the second one, where I was a guest speaker. And they asked me to speak on the subject of valves, tubes, and CW. And so
your strong suits, by the way.
Yes, right. So I said, well, this is almost like brown shoes with a tuxedo. So in keeping with the tuxedo, I had some formal attire, and I'm wearing my black bow tie.
It's quite dashing. If you put your beret on, you might actually blow some fuses out there in internet land. But that's really great. Anyway,
but I got few comments. I mean, it was just like it was accepted. I was supposed to have my black tie on.
They're very calm people. They don't react emotionally the way we do, Pete. And so they probably just took it all in stride, stiff upper lip and all that.
Or how perfect.
Or finally, we have someone who's appropriately dressed for the GQRP Club convention. All right, we'll talk about the convention and your speech there, and your return to thermotrons and continuous wave Morse telegraphy in a moment. But I wanted to mention something at the outset. I spotted something on the internet that was kind of interesting. I've been a big fan of Rod Newkirk, W9BRD, who used to write the How's DX column for QST magazine. I just love that column. It was one of my real introductions to radio, amateur radio, because he'd always have these reports coming in from Vlad down at Vostok Station talking about, life down there at the South Pole and things like that. Very, very cool. His son, David Newkirk, now has his call, and David is quite a prolific writer and home brewer himself. But I went to his website, and there was a little article in there in which he was looking back at some of his dad's early QSL cards. And he noticed that along the bottom there was the standard set of letters that you'd see: DXCC, RCC for the Rag Chewers Club, A1 Operators Club. All these that worked all states, worked all continents, WAC, WAS. But then there was one acronym that he did not recognize: WFSRA. WFSRA. It appeared on several of the QSL cards, and I see a quizzical look on your face.
Yeah.
And you didn't know about it either. Neither did
No.
I.
No.
All right. It stands for the World Friendship Society of Radio Amateurs. The World Friendship Society of Radio Amateurs, the WFSRA. This is something that popped up in the 1930s, and it was largely in response to the carnage and bloodshed of World War I. This was in the interwar period, and there were a lot of these kind of international peace and understanding organizations that popped up. The WFSRA was one of them. And now, to join the WFSRA, all you had to do was to write out and sign with your signature and call sign the following statement. It's the sole obligation for membership in the society. Quote, I hereby promise that I will, to the best of my ability, make such use of my amateur radio station as will be conducive to international friendships, that I will never voluntarily permit my station to be used as the tool of selfish nationalistic interests, and that I will do what I can as a radio amateur and as an individual to promote world peace and understanding, to be followed by the signature, address, and station call sign. Membership in the society is open to all amateurs in all countries. All that is necessary to become a member is to copy and sign the pledge and send it to the secretary, Dwayne McGill, W9DQD, 730 North 6th Street, Grand Junction, Colorado. Been there. USA. Copies are preferably to be made in English or French, but they may be made in the language of the member. So, WFSRA.
And that occurred at
Pete,
a curious...
hold on, wait a second. Hold on, I got to jiggle my knob here. Can you hear me?
Yeah.
Okay, good. I'm having problems. Go ahead.
That occurred at a curious time in history in the 1930s.
Yeah.
Oh man, lots happening in the world. Wow.
In the interwar period. But anyway, the mystery is solved. WFSRA, and I'll report later on. We have at least one new member. We'll talk about that when we get to the mailbag.
Who? It's still active?
We may be reactivating it.
Oh, okay.
I think it's sort of similar in spirit to our IBEW, the International Brotherhood of Electronic Wizards.
Yeah. Okay.
But anyway, speaking of wizards, Pete, you have been very active. And let's turn now to what's on Pete's bench.
Okay. First, I'll start with the pimp.
I love the pimp. I mean, I want to say, okay, tell him what the pimp is, and then I'll take credit.
Okay, Joe Gillespie, W4IMP, came up with this 3-tube transmitter. And you spoke about that.
SSB transmitter.
SSB. You talked about it in the last podcast.
Right.
So I said, okay, maybe I ought to try my hand at that. And you said, oh, that's Pete's imp, the pimp.
I said, I actually warned against it. I said, we have to be careful because the rig is known as the imp because W4IMP. And then I said, if ever people start referring to it as Pete's imp, it'll become known as the pimp.
Yes.
And also, I must say, our viewers and listeners might not be aware of this, but the picture that you have attached to your Gmail account shows you in some, well, how should we say, rather flamboyant attire.
Yes.
Including a large mink coat, sunglasses, quite a bit of bling. And I think there's actually a feather sticking out of your head.
A pink boa.
A pink, yes. So it seems vaguely pimpish.
Yes.
So now we find that Pete Giuliano is building a rig called the Pimp. But go on.
Riding a subway.
That's it.
Okay, so I have built it, but it's not operational, and I'm having a little difficulty. But let me start with the good part. First, it uses two 6U8As and a 6CL6. That's the 3 tubes. And one of the 6U8As is the BFO carrier oscillator, and that's the triode section. And the pentode section is the microphone amplifier. And it calls for this transformer in the output, the standard out plate to grid transformer. Right. And that transformer can't be found, and something that will be a substitute. UTC used to make what's called the sub-ouncer transformer, these real small transformers. They're $100 if you can find them. So I said, man, there's got to be a better way of doing this. So I discovered you can take a 600 ohm to 600 ohm modem transformer, and instead of putting that in the plate circuit, put it in the cathode. So it becomes a cathode follower. So you have the modem transformer connected to the cathode, and then you have the standard cathode bias, the resistor and the capacitor on the other lead. It works, Bill. You can put costing $1 modem transformer and get a couple volts of audio out of this. So I think that's a little innovation that if you wanted to build this thing, you'd be really stuck to find that transformer, the normal plate to grid output transformer, and you can find it at a reasonable cost, and it's really big. The modem transformers are small. So that's an innovation that I came up with that works. And there's some documentation in the internet that says, yeah, you can do this. So first thing, so it's got an audio. I've got a balance modulator in there. I really don't like the 2 diode balance modulator, and I think one of the problems is I put some Schottky diodes in there, and they ain't working too well. So
I did something similar with one of my early diodes. It just seemed to me like Schottky diodes were the way to go. And I put them in there in a balance modulator, and I could not get them to work. And I was pulling my hair out, and somebody said, just put some regular old diodes in there. And I did, and Bob was my uncle.
Yeah, so I need to just pull them out and do that. But anyway, I got taken over by something I spotted on eBay.
It happens, Pete.
And I spotted a National NCX5 with a linear dial readout.
Oh, man.
For $61. $61. So I bought that sucker, and $2 worth of parts fixed it.
That's beautiful. So I've been looking at your blog there, and I see the fun that you're having with that thing.
Fascinating with the NCX5. It has a mechanical digital readout. Like the old Vita root counters.
They click while you're turning them.
Click, the R398. But it also has something interesting, and I see the hand of James Millen, who used to do design work. He did a lot of the mechanical HRO with the gears. This thing has got so many gears in it. When you switch bands to 80 and 40 meters, there's a shuttle system that switches in new digits. You know how you have the problem that in one direction it'll read, the numbers will go up in the other direction, like on the multi-dial analog readouts.
Yeah.
You read it one way, turn left to right and it goes up, turn right to left and it goes down. But when you switch bands, they have different dial scales.
Right.
So they did this mechanically with this mechanical digital readout. Actually, a shuttle system. When you switch to 80 and 10, it shifts the digits in the window.
Oh man!
And you know what? It's linear. It really is linear. None of this stuff.
This is so wonderful. This is like Pete is being pulled back into the world of analog VFOs, linear dialed readouts.
Except there's a problem that they didn't, like the Japanese. They did not pay attention to design for manufacturing and assembly. The 2N706, it's a hybrid rig. It's got a 2N706 VFO in it, and they got the VFO buried underneath the main gear. You cannot, and it's got a socket in it. So I thought I had a bad 2N706. There's no way to get that.
They just did this to make life interesting for you 60 years later.
I have a pair of right angle, tweezers.
Yeah.
You could not get in there to grab that transistor to pull it out. you could not replace the transistor's replaceable. It's a socket.
Oh, I hate
So I had
sockets on
so,
transistors.
so I had to disassemble the VFO to replace the transistor.
But
So
were you able to do it?
yes,
All right, good.
and
Down. Did you go back with the socket or did you solder it in?
no, I just left the socket.
Okay.
So interesting thing is there was a warble when you would tune, even though it's mechanical and precision gears, there was a warble. And when I took the cover off the gears, they actually have two capacitor sections on a common shaft. And I think when it gets to the higher frequencies, they shift to the other capacitor and they maintain a linear readout, but it's like on 10 meters, it's a lot less.
Yeah.
In other words, to get you the 500 kilohertz spread, they use a smaller capacitor. And it has on a common shaft, and typically they have these little wiper tabs that are like brass that fit on the rotor.
Yep.
And so I said, you know what? I bet you this thing is corroded. I hit it with deoxit and the warble went away.
Oh man.
But I mean, it just.
Well, Pete, that reminds me, that's one of my earliest kind of tube type repairs when I was getting back into ham radio in the early 90s. I picked up a Heathkit HW101 and it was going great, but the VFO was kind of squirrely. I would tune it and all of a sudden it would start getting jittery and jumping around. It was driving me nuts. And I was going in there looking for bad components. And it was one of my early uses of the internet for troubleshooting. Finally, I went out and I think I went to the boat anchors mailing list and I said, man, I got this squirrely VFO and I've done this and I've done that and all the components seem good and I can't figure it out. I didn't even really know. An old timer out in Arizona shoots me an email and he says, hey, Bill, give it a shot of deoxit down there in the main tuning cap and especially around the reduction drive, Make sure the contacts are clean and the reduction drive is well lubricated and the squirrels will go away. I went in there, zip, zip, and instant satisfaction. I said, man, it was so great. It was like the power of the internet, the power of tribal knowledge came into the shack. So fantastic.
Absolutely. Yeah. So the thing is, this is really a excellent design. By the way, that thing cost equivalent today about $5,500 back in 1960.
It's a beautiful looking thing too.
Yeah, and it's heavy and it really sounds good. And the mechanical digital readout makes a world of difference. I mean, there's a world of difference between the NCX3 where that dial is variable, you know. So it's a real mechanical readout and $61, Bill. And then $2 worth of parts. It had a bad diode. You know, usually they have two diodes in the AGC, and one of the diodes was, I mean, the S meter wasn't working, so we replaced it with a 1N914.
Oh,
10,
all right.
10-cent diode, you know.
Good.
Boom. There you go.
There you go.
Which leads me to the second radio that I've been working on, and in the background on my Skype is a Collins KW1. I bought this like over a year ago, and I had been working on it, and all of a sudden, the receiver went dead. And I could not figure out, you couldn't even hear the crystal calibrator. I could not figure out why the receiver went dead. I mean, I replaced some capacitors in their electrolytics, and I didn't, you know, nothing came to mind. So I said, okay, I'm just going to put it in the shelf and I'll think about it a bit. So I said, this is a good time to pull it out. So first off, I'd like to recommend a tool that you can buy that is really found very useful. And these people who do the beads, you know, make the beaded jewelry.
Yeah.
The beaded jewelry. They sell this tool that looks like a oversized sewing needle. And they use it to pick up the little beads, like to get your hand to get put on it. And it's about maybe 3 inches long and it's down to a point and it's really thick at the shaft. So I use that to pick around radios, and it has an insulated handle on it too, which is
it's like a tiny chicken stick.
Yes. So anyway, I'm moving some things out of the way because I'm doing some circuit tracing. I'm moving some things out of the way, and it slipped out of my hand. It slipped out of my hand, and it hit the plate of, they have three 6AL5 diodes in there. They're vacuum tube diodes. Vacuum tube diodes of all things.
6AL5s, yeah.
6AL5. Slipped out of my hand. It hit the plate, one of the plate resistors to ground. And I said, oh man, I'm waiting for the smoke. All of a sudden the radio came to life.
The radio gods have spoken.
Yeah. So I said, wait a minute. This cannot be right. This cannot be right. I mean, normally that thing is never grounded. This cannot be right, but it makes the radio work. So I said, okay, something in there is not grounding
Open.
when it should be open. So I'm looking at it, and they have three relays in there, and it's not just like a double pole, double throw relay. They got like 8 or 10 contacts on them. So I mean, it's spaghetti, each of the relays. So I looked around and I said, what would do it? And I looked, the RF gain control has a resistor off of one of the leads, and that small value resistor, that resistor connects to the wire, and that connects to a relay contact that on receive, it's grounded. So I put my ohm meter from that resistor to ground, and it's open. So I traced it back to the relay, and I looked. And if you just look superficially, it looked like the wire is connected, but the wire was broken off. I would have never found that. I mean, I've looked at it 100 times, but it just it was sitting in the wire bundle, so that when you look at it, so oh yeah, that's connected, but it wasn't, and I don't know how it got broken off. But anyway, that fixed the receiver.
This can't be the radio gods. This has to be the other team at work here. This is bad news.
Yeah. So anyway, I don't have the transmitter working yet, and I think there's a similar problem, but the receiver's quite good. And which brings me to the point, I actually, because this only tunes from 20 through 10, I actually listened on 15 and 10 meters FT8. It's active. 15 and 10 meter FT8. Now forget the FT8 part of it. Just think about the band is open.
That's good news. That's a good thing.
That's the good part. I mean, before you used to be able to hear the CW beacons on 10 meters. I heard no CW beacons, but I did hear the FT8 signals. So the band, and indeed, cycle 25 is delivering the promise that we talked about.
It's kicking in. Now, The other thing I want to ask you about is the many direct conversion receivers that are the result of your design being built worldwide. Tell us about this.
Okay, so the last time we talked podcast, we were 72. We're now at 80, and I actually have pictures of guys who have built stuff.
80 direct conversion receivers.
Yes.
All right.
Request for the code. So I still think probably we'll get about half of those, maybe 40 are actually built, because guys are pretty serious. They'll ask me follow-on questions, and I can't understand why.
Why what? Why?
Why there's interest.
Because they're building something. Because it's a receiver. You could build a receiver, which is like, for me, that was always one of the cool things I wanted to do. This is why I struggled to build a Hearing Aid 5 receiver, because somewhere along the line somebody had told me that all true radio amateurs, at least at one point in their time as a ham, have built their own receiver, right? Have actually used something they built with their own hands to listen to radio waves. And you, Pete Giuliano, N6QW, through your design, are providing them with that opportunity. So I understand why.
Well, I think too, it's because it's the Arduino. I mean, you could have just as well put an analog VFO. I mean, a 7 megahertz analog VFO is pretty simple to cobble together and be able to use with that and have a working receiver. But it's the Arduino, because a lot of guys, you'd say too, well, one guy wrote me and said, well, I bought this encoder and it skips digits. So I said, how much do you pay for the encoder? He said 40 cents.
Spend 80. Hey, but listen, getting back to the why to build this thing, it reminds me of something that Farhan wrote a long time ago. Farhan actually designed and built with his cousin. His cousin was a student in electrical engineering or IT in India. And so she needed to do a project, and the two of them together built a simple direct conversion receiver. I think it was for 40 meters. And his uncle or some other family member looked in as they were doing it and said, why the heck are you doing that? And Farhan's answer was, we do it because we can. We have opposing thumbs. We're the users of tools. We build things, which I thought was right on the mark.
Yeah, I think that's the case. But by the way, can I have about 10 seconds to rant? A
Yes,
10-second
yes.
rant.
Okay,
Okay.
rant alert on.
Okay, rant alert line. Okay. About 9 or 10 years ago, I converted an HW 101 with a digital display.
Hmm.
So I get a YouTube comment yesterday from a guy who says, "How dare you?" He said, "You cobbled up, you destroyed that HW 101."
Shocking.
So I said, "Well, first of, I didn't destroy anything. All I did was I fixed a drift problem on the HW 101 and I put a digital display on it." He said, "Well, he said, if I owned one, I would have kept it stock." I said, "If you owned one, you'd realize it drifts." And having a digital display, makes so much difference. So, I mean, there are people out there that are making judgments without knowing the facts. I said, first up, before I even put the digital display, I did all the service bulletin changes. I changed all the capacitors out, changed the odor rings, lubricated everything. And when I got done, I had a drifty transceiver that you could 5 kilohertz tick marks. I said, you're going to get on frequency. You're going to get that comment. So why are you making judgments on that? You don't have one. You've never had one, and you don't know what it sounds like. So why are you saying you destroyed it? I didn't. I didn't destroy it. Matter of fact, it took a lot of effort to make it look good, to have that LCD display fit square. It looks like it was made in a factory.
Pete, can I join in your rant here?
Yes.
Okay, I was going to rant about something similar, and I've discovered this. I think and it's been in the news a lot lately, but it's a problem with social media, and it's especially acute on Facebook. And I'm finding it really annoying. And what it is, it's based on the fact that the algorithm for a lot of these social media sites, mostly Facebook, reward what they call engagement. In other
Hmm.
words, if you write something that causes somebody to respond, then you get extra points. They actually put a little applause symbol next to your name if you get a lot of controversy, a lot of engagement, as they put it. They've also, and this is what the person who was testifying about this week talked about, they've discovered that anger and kind of bile is the best promoter of engagement. So you get relatively few messages that say, "Hey, that's really wonderful. I like what you did with the HW101." That doesn't provoke controversy. But if somebody comes back and says to you what that guy says to you, that's engagement. Oh, that's good. Listen, I had something similar, and I'll mention it now since we're ranting. But I recently picked up the VFO that I wanted, that I had as a novice, the Globe Electronics V10 VFO Deluxe, deluxe with an E at the end, which means really deluxe. Anyway, I got this thing, and before it came, I was looking through the schematic, and I realized it has a selenium rectifier in there. Pete, what do you usually do with selenium
Get
rectifiers?
rid of them.
Get rid of them, right? Right. That's something I always learned. And I didn't even remember why. I had this vague notion that they were somehow radioactive. They're not. It's vaguely toxic. But the thing is, they will fail, especially after 60 years. And when they fail, they stink to high heaven, right? So while you're at it, take it out, replace it with a silicon diode like a normal person, and put a little dropping resistor in there to take care of the difference in voltage drop. The selenium rectifier drops about 5 volts per rectifier, whereas the silicon diode drops zero point 0.6 volts, right? So you got to have a drop. Okay, I did it. Some guy comes on the Facebook page and makes, snarky comments about how I'm defacing. It's not necessary. This very kind of, not in a very kind of arrogant kind of, I don't believe that silicon rectifiers should be removed in this way, defacing rigs that are perfectly serviceable. And I saw something similar. I was surprised. I said, why would anybody bother to do that? I mean, how controversial is it that I want to replace the silicon rectifier? If you don't want to replace your selenium rectifier, old man, Great, leave it in there till it blows up and stinks. I don't care. It's your piece of gear. But he felt compelled to kind of poke me and say, to imply that I had done something wrong. I saw something similar about a year ago, and I couldn't figure it out. When I had recapped an old radio, the capacitors, you got capacitors in there that are 70 years old. They're so dry, they're not even capacitors anymore. Change them out, put in new caps. If you want, you can go to Hayseed Hamfest and get one that looks like the old one, but it's new. Some guy wrote back and said, this is really controversial. This is a very hot button topic. There's a lot of anger about this. I mean, come on. This is like fake controversy, fake antagonism. And I'm kind of tired of it. So I'm thinking about just dumping the whole Facebook thing, because if they want to stoke controversy, go for it, but don't include me.
Do you still have the selenium rectifier?
I do. I have it right here.
Okay. If you feel so inclined, take it apart and get some paint remover and take the coating off. You can turn that into a solar panel.
I know, a photo cell. There's all kinds of weird stuff you could do with that. Some guy, I got a nice email from a fellow who was saying that in his radio club at high school, some kid actually did that. I said, man, that sounds like a really cool club.
Yeah, there you go.
All right. So anyway, rant concluded. All right. Everybody chill out. If you want to take out your selenium rectifiers, or you want to put digital readouts on your Heathkit HW101s, have at it. But don't get mad at us if we do it, because there are radios. So we can do whatever we want. Okay.
Yeah, you got
it. Hey, listen. But speaking of problems, you discovered that the part shortages that we've been hearing about are real. This is real. This is really a thing.
Yes.
And I understand it's affecting SI 5351s.
Yes.
Which has, of course, left me heartbroken.
Yes. Actually, Hans Summers issued a bulletin that there's a replacement part that's called like an MM.
Yeah.
5351, and he said they're even better, and they're available. So there's a replacement.
But Pete, this is going to spark. We should start a rumor that the SI 5351 has far superior phase noise statistics. The phase noise problem has been solved. Yay!
But interestingly enough, I have the HL2, the Hermes Light 2 SDR.
Yeah.
And this thing is really catching on, and so they build them in a 100-piece lot. And they had a recent build that got started in late September, and more than 100 guys signed up, paid their money, and then they issued a bulletin that says, can't get the parts. And they don't know when the parts are coming. They said it'd be, yeah. And I found something interesting. They were reflecting on the automotive industry, and they said, well, part of the problem is the automotive industry has failed to update the processors, so they're using this old technology, and the new plants are not building this stuff anymore. So why don't the auto guys get in line and start using more modern chips, because that's what's coming off the lines, not the old chips. Why are you blaming the auto industry? There's something wrong with supply and demand, and I think the problem is us. We put so much of that stuff offshore that we lost the ability to build that stuff. And you can't turn on the fab overnight. You got plants.
They had the guy from Intel on 60 Minutes not long ago, and he was saying that they just can't make these kind of chips anymore. It's all going to TMC, the Taiwanese manufacturing company. Yeah. There's one plant over there that's doing most of the kind of high level integrated circuits manufacturing there. So yeah, it's a big problem. But it's amazing how it is impacting on ham radio, but it's not affecting that KW1 that you have behind you there, Pete, nor that CW rig that you built for the GQRP club. But let me ask you this. I missed your lecture, your talk to the GQRP club convention, and I'm waiting with bated breath for the YouTubes to come out. I'm sure they're coming out soon. These things take a little while, but when they come out, we're all gonna watch you talk about building a tube type CW transmitter.
Correct. As I understand it, it won't be till January that'll be open up. Right now, they're unlisted. If you were a member of GQRP Club, you can get access. They sent out the listing, or if you had signed up I'm sorry, if you'd signed up to participate, they gave you a link that you could watch the video. And for the general public, it's going to be in, I think, January. I may be misquoting something here, but I think it's a period of time. Anyway, it was a lot of fun, but there was a problem. And let me
What
tell you
happened?
about the problem.
What
Well, the
happened?
problem is they had everybody update to the latest Zoom. So
Uh-huh.
they were adamant. They said, you need to update to the latest Zoom because we're updated to the latest Zoom. And when you look at the presentations, it's got black squares all over it. so, so
That's one of the new update features.
yeah, so the guy that was running the show was trying to remove the squares. I mean,
It's
if you
like
clicked on
whack-a-mole.
it, yeah, you clicked on it, he went away. But it was kind of interesting. And the thing that I found very curious was when they came to the question section. One question I got is, "Tell me about using CNC milling to make circuit boards."
Oh, yes.
So I said, "Okay," but if you look in
Right in
the
time for the part shortage.
yes, if you look for the latest Sprap 188,
I have it in, I
you'll
have it
read
right
an
here.
article by me about circuit boards
I've
making
enjoyed it.
CNC.
I thought you were going to talk about how it cost you $250,000, but I didn't see that line in there.
Yeah. But other people, but you know who may be getting a machine? Grayson.
Dean
Grayson.
Grayson. I think
Yeah,
Dean already
Dean
has
Spellman.
one. Dean,
Yeah,
Dean has one.
Grayson.
I
Grayson wants
I feel out of it. All the cool kids are getting CNC mills.
yeah.
Oh
Well,
man.
the price is down $350 so
Yeah,
far.
but yeah, you better act fast because well, I mean it's too late. The part shortage is going to definitely affect
Yeah.
this thing. All right.
Well, Grayson was interested in cutting the 2.5 inch round meter holes.
Uh-huh.
He got tired of the drills and the
Oh yeah.
pile.
Yeah, yes. He's taking a huge leap. He's going from like 1947 to 2022.
Yeah, yeah, yeah.
All right. Well, we'll look forward to those videos.
That's it.
Hey, Pete, you so many of the things that you said just resonated with things that I wanted to mention. First, FT8. I tried it. I tried it. I actually built the interface board with some boards that Rogier had sent me, and with your TR circuit, got it to work. Got on 17 meters. Tried it. Worked a whole bunch of stations. Worked some Japanese stations. Worked a lot of DX. Worked about 25 countries without even trying. Look, it's just I discovered that it's not for me. I tried it. I didn't really like it. I found that it left me kind of edgy in a way that that a nice SSB kind of rag-chew QSO does not. And I just found it was just very kind of impersonal. It was like machines talking to machines. Now, look, this is just me. I mean, I know a lot of guys love it. To each his own. Knock yourself out. I just didn't like it. I found it's sort of the one thing I liked about it was that it was automatically decoding the characters. We weren't having to train our brains to remember that dida is an A or dit is an E. For me, that still seems kind of barbaric. We'll talk about that in a moment. But after that, I mean, it was just so automated. I mean, it would sit there, and it was even more impersonal than CW because if you didn't look carefully, you wouldn't even know what report you gave to the other guy. You certainly wouldn't know what report he gave to you, and it would all automatically log, and the whole thing would just sort of take off. And I just it was not my thing.
Well,
I tried it, not for me.
I discovered something I didn't know. Most of the time when I operate FT8, you see a station calling CQ and you click on it,
Yeah.
and then the next round it calls them. Guys have automated this. This one guy was saying that he makes 3,000 FTA contacts a day, and he's not even at home.
I know. I see. I predicted this. I did a blog post on it. I said, just this looks like we're just a few Python line codes away from completely automating it. You don't even need to be there. I said, has anybody done that? You just answered the question.
Yes.
Yeah.
Yeah.
Okay.
And
Yeah.
and he was kind of perturbed because his computer had a glitch and he one day he only made 1,999 contacts.
Oh my God. All right. Okay. So anyway, you guys have fun. So then I went to the opposite end of the spectrum, I guess probably in reaction to the FT8. But I mentioned that I finally acquired a Globe V10 VFO Deluxe, Deluxe with an E, which means it's really deluxe. I got one off of a fellow that was talking about it on Facebook. And so this allowed me to put together my entire novice, my real first novice station, which is the Lafayette HA600A receiver with jeweled
Jeweled
movements,
movement.
jeweled
Yes.
movements, no doubt. And then with a DX40 transmitter, which I found out has cathode keying about 100 volts across the key terminals when everything's working right. How did we survive this, Pete? I don't understand. And then now that I added to the whole mix the Globe V10 VFO Deluxe with an E. So I had my whole novice station there together. I finally, and I actually made it better than I did as a novice. I mean, I know that I did not know how to do the TR switching as a novice. I don't know what my level of knowledge was, but I know it was far below what's required to mute the receiver, allow for side tone, switch the antenna, and turn the transmitter on. But I did that. I had a 3-pole double throw relay. I rigged the whole thing up. So actually, the station that I ended up with was superior to the station that I used as a novice. But still, I got out on 40 meters and I made a bunch of contacts. I was talking to all kinds of people on 40 meters. If I could hear them, I could work them. It was fine. But I didn't like it. I, I thought I would have this sort of nostalgic feeling about my original station, but instead I was reminded about why I desperately needed to upgrade the receiver. It's no fun using a Lafayette HA600A on 40 meters. Forget about 15 meters. Holy cow! It's got a 455 KCIF. The opposite, the image suppression is horrible. The VFO is unstable. If you bump the workbench, the thing jumps, 5 or 10 kcs. The VF1, the V10 VFO is very nice. It's nice. It also has very linear readout across. You look across the band. They managed to kind of to crack the code on this. They used a series tune clap oscillator.
Well, Globe Galaxy, yes.
Yeah. And so and this is like 1963. This thing came out. But the other thing I discovered was this equipment is really large and heavy. Even the DX40, which I considered kind of a small rig sitting next to the DX100, it is small. But when you compare the size of these things to some of the rigs that we're using now, to the BitX rigs, they're enormous. They take up huge amounts of space. They're heavy. They make a lot of heat, and they're clunky.
Drift.
And they drift. And not only that, I was also reminded that I'm no longer a CW guy. I used to be a big CW guy, not anymore. I can do it, but I don't get a lot of joy out of it in the way that I get from an SSB or even an AM contact. So after I worked a bunch of these things, a bunch of these contacts, I took it off the workbench and it's back up on the shelf. Been there, done that. I might take it down during novice rig roundup or something like that. But that was the end of my adventure with the novice station. And cathode keying. Oh yeah. One good thing I did work. One of the stations I worked on 40 meters, and I didn't recognize it at the time. I talked to Bill Kelsey, N80T.
Oh, yeah.
Yeah, and it's funny. I guess I was the victim of my own station because the V10 VFO was kind of cold, so I was drifting a lot when I was talking to Bill, and signals weren't great. And it took me at first I didn't recognize it, and I signed with him. And I said, "Holy cow! I had worked Bill, And then I sent him an email and said, "Man, I'm sorry, I was distracted by my drifting VFO." So anyway, that was kind of fun. Hey, but it, I am going into the imp mode in a similar way because you are working on the imp or the pimp, and I have taken off the shelf, and people who are looking at the video can see it in the background there. My mate for the Mighty Midget receiver. This is a receiver with 3 6U8 tubes, all 6U8s, just 3 of them. But it is a single conversion superhet with the IF at 455 kcs, designed by Lou McCoy and described in a QST article in 1966. I built mine on the chassis of an old Heathkit Benton Harbor lunchbox. I'll probably be criticized for this by your friend, Pete, but I did it.
Is that
Anyway,
a Drake? Is that a Drake knob?
It's got a Drake knob on it. Yes, it does.
I
It's
can
got a
spot that from here.
knob from a Drake 2B. Yes, and it's
Yeah.
got a CD-ROM for the frequency readout, and
Cool.
it's quite nice. But anyway, there's another guy, Scott WA9WFA, who is also building a Mate for the Mighty Midget. He's been building it for a while, and he had a lot of trouble with it. So he built a second version of the receiver spread out on not really kind of alfresco style, but on a larger piece of copper-clad board so he could separate out the stages. And so his questions have sort of caused me to kind of go back and reconsider some of the things in my Mate for the Mighty Midget. And also there's been some email traffic. One thing somebody raised, they said, wait a second, look at the diode detector in the Mate for the Mighty Midget. Lou McCoy has a 100 picofarad capacitor at the input to the ceramic, to the diodes, and at the output. On both sides of the diodes, he's got 100 picofarad capacitors. Isn't that kind of low for audio? Indeed, it is. So I started thinking, well, what values would be better there? I fired up LT Spice. I used LT Spice, and I basically just built the diode detector from the Mate for the Mighty Midget and took a look at how it worked with 100 picofarad capacitors at the input, at the output. And then I switched. For the output capacitor, I just switched in a 0.1 microfarad cap. And boom, significantly better, a lot better. And then I tried it in the real world. I just swapped out, actually I put a 0.1 microfarad capacitor right across, which makes it effectively 0.1 microfarad. Boom, a lot more audio. So there's an improvement that was noted, discussed on the internet, checked out on LT Spice, and then incorporated real world. Here's the other thing I was working on with this thing. I was never able to get the crystal filter that Lou McCoy described to work. He built a crystal filter using two FT241 crystals from World War II. And these are crystals that are operating in the 400 to 500 kilohertz range. And he has two of them in there, kind of in a half lattice filter. And if you read the article, he's like, well, if you try two of the same value, you'll have a very narrow filter. If you try them spaced 5 kilohertz apart, it'll be good for SSB. Experiment a lot, see what you can do. Well, first of all, even at the best of times, a lot of these crystals were bad. I was reading Don Stoner's The New SSB Handbook from 1959, and Stoner was saying in 1959 that I think about 1/3 to 1/2 of these crystals in the 400 to 500 megahertz range were in 1959 bad, right? That's a long time ago. That's 62, 63 years ago. These crystals haven't gotten any better with age. They've been sitting around in musty basements and stuff. So it's real hard to get filters at that value and get them to work right. But then I remembered something from my Q31 receiver adventures. Why not use ceramic resonator in there?
Yeah.
Put a ceramic resonator in there and use that in lieu of the, no pun intended, Lou McCoy, but in lieu of the crystal filter that McCoy recommended. And so I rummaged around the junk box, and I had a ceramic resonator that is plus or minus 3 kcs. Now, not to be confused with the 3 kc bandwidth. Plus or minus 3 kcs means it has a 6 kc bandwidth, right? It could go up or down 3 kcs, which is a bit too broad for SSB. But I put it in there just to see if it would work. It works fine. It really does improve the selectivity. I'm able to get good opposite sideband rejection. And so I'm going to use this, but there is another, there are these little black rectangle boxes. And I have the one that is plus or minus 3 kcs. They have one available. It's called a 455 IT, plus or minus 2 kcs. Now that would be good. It would still be about 4 kcs wide, which is just about 1 kc more than you really need.
I think you need to find a CK455J, which is made for, it's plus or minus 1,
wow.
Which gives you, see if you can find.
Yeah, that would probably be good. Yeah, that'd be 2, and then because the skirts are wide, it would be wide enough. So yeah, all right. So if anybody has any of these parts laying around, let us know. Either the 4kc one or better, the one that Pete just described.
If you remember the Epiphyte.
Yeah.
The Epiphyte.
Sure.
Sideband thing. Yeah. That's what they used. They used the CK455J in there.
Attention, British listeners. If you got any of these laying around, let me know. Hey, but this is related to your description of the difficulty of changing the transistor in the rig that you were working on in the NCX. So here's what happened to me. Before I put the ceramic resonator in there, I was using one of these fancy Millen. You mentioned James Millen. One of the fancy Millen IF transformers. Millen made this IF transformer called the 61455. It is a beautiful piece of work. It is slightly bigger, metal box, little box. Yeah. But if you open up that box, he's got two variable capacitors in there, fairly large, two of these really nice inductors, and it's basically an IF transformer, high Q. The Q of this thing is about 200, Q about 200. And so my bandwidth. Yeah, my idea was to get this thing and tune it up right and use this as a substitute. Now, it advertised a bandwidth of about 4.7 kcs at 6 dB down, right? But then the skirts are wide, so it's not going to be as good as the ceramic resonator. But I was figuring, okay, I tried, and I put it in there, and then I started thinking, well, let me tweak this up a little bit and see if I could get it so it's got decent bandwidth. So I start fiddling with the peaking the two coils, and then they've got a third little screw in there that is the coupling capacitor between the two parallel LC circuits. So I'm watching the scope and I'm turning this knob and I'm watching to see how it's changing the passband characteristics and the 455 kc through, and all of a sudden I hear click, boop. Ooh. The screw, when you're turning it, when you reach the bottom of the threads, inside the capacitor is one of these little cylindrical capacitors, the screw just falls off inside the capacitor. Thanks a lot, James Millen. All right. Yeah, at least you could have put something where it would stop.
Yeah.
No, because you're not even really looking to see where you are. You're just tuning and tweaking the thing, watching the scope. It falls inside. How are you going to get this out? Now I can see it in there. It's like laughing at me. I shine a light down there. It's inside the cylinder, but it's off the threads. It's down below inside. I tried turning the thing over, and I tried putting a screwdriver on it to get it to grab the threads. But every time I touch it with the screwdriver, the pressure from the screwdriver pushes it off the threads. And then if I try to bring the screwdriver down, as soon as I get to the point where it's on the threads, the screwdriver loses it and it falls again. What the hell am I going to do? Now, I thought about just throwing the whole thing away, but I've got the manual on it. This thing was built in 1957. This little IF transformer is in itself a bit of a kind of a useful and important, device. So I'm starting to think, how am I going to do this? How am I going to do this? I did it. See if you can guess how I did it. How would you do it?
Did you remove it out of the circuit?
I took it out of the circuit. So I've got the device sitting. I took the case off, but that doesn't do you any good because it's inside the cylinder of the capacitor.
I don't know. I'd have to put my hands on.
Well, here's what I did. It was a hazardous, scary, I'd say gutsy repair. I have a screwdriver that's just about exactly right to fit on to the kind of the slot on this screw that's supposed to go into the threads. And I took a very, very small drop of Gorilla glue, acetone glue, right? The acrylic super glue, very small dot. And I very carefully dropped the screwdriver into the capacitor, being careful not to hit any of the threads. And I put the screwdriver right into the slot on the little screw slug that does the tuning. And I held it there perfectly for several songs playing on Pandora until I figured the glue had done its thing and grabbed it. Then I carefully pulled it up, and as soon as I saw it hit the threads, I turned it and it grabbed. I pulled it out. But that was oh man, I said some very unkind things about James Millen at that point. But anyway, it was kind of a fun repair. Hey, I talked about some of this kind of stuff to the Vienna Wireless Society, which is Dean's club, my club too. I was a member of this club for years, on and off, but I'm going to get back into it. And we had a nice session with his builders group, and that was really very gratifying because wow, you were talking to a bunch of people who are interested in our kind of stuff, and they hadn't been previously until Dean created the builders group and brought these guys in to build your super SSB transceiver. None of these guys had really done much building at all. And now he's got them building SSB transceivers.
And they're going to look at a DCR.
And they're looking at the DCRs as their next project.
Yeah.
But I really enjoyed the session with these guys. And I'm not big on radio clubs, but I thought, wow, this is the kind of radio club meeting I'd like to go to, because the questions were like really good questions. Some of them were focused on stuff that you had said. You had pointed out correctly, for example, on your first transceiver, it's probably not a good idea to homebrew your own crystal filter, right? And they noticed I was talking a lot about my Mythbuster rig with the 10-pole homebrew crystal filter at 5.2 megahertz. And so I talked a little bit about how to do that, how I did it, the approach that I used, G3UUR, the different kinds of software, the kind of cut and try and experimentation. But it was just so great. I said, there must have been a time in ham radio where these kind of encounters were not all that unusual, where you could walk into a radio club and find at least a subset of guys who are actually building things. Today, it's rare. I mean, it's pretty rare. But then again, these rare encounters are kind of brought together by the internet. So GQRP and Vienna Wireless, yeah.
One of these builders I chuckle about. This guy is very colorful. He has included LEDs in all parts of the circuit.
I love it. Yes.
So when you key the mic, the whole thing lights up. He's a different color, red and green.
He asked me a trick question because I had admitted that I used one of these tiny little boards, these LM386 boards as the audio amplifier, because I had a whole bunch of them. I said, heck, 11 of them for $10. Why not? Put it in there. So he very kind of carefully says, I wonder what your experiences are like with using this board, whether you consider it a positive thing or did it work well for you? And of course I said, yeah, work fine. And his face lit up. He was like, yes. And apparently this had been a cause of controversy in the club. But then I added icing on the cake. And I said, that little board, it comes with a red LED. It turns on when you turn it on. He said, yes, you like it. All right. So anyway, that was really good. Hey, one thing I want to say, I'm as you mentioned Sunspot cycle and cycle 25 coming back. Indeed, it is back, and now I am thinking I got to put a beam antenna up on the roof again. I'm torn. I'm still torn. I want to build my own antenna because it seems wrong to connect a store-bought antenna to all this homebrew gear. But I also want to have both 20 and 17, and that's hard to do with a Moxon. But then again, there's this design out there by N3OX, November 3 Oscar X-ray. And he built a dual band Moxon for 20 and 17. He switches it. What he does is he builds it for 20. First of all, he built a 20 meter Moxon. But then he has two relays. On the reflector, the relay switches in a capacitor that effectively shortens the reflector to 17 meter electrical dimensions. For the driven element, the relay switches in on the other side of the antenna an L network that again causes that driven element to look like 17 meters. So you throw the switch in the shack, two relays up on the antenna click in, one shortening the reflector and one matching 20 meter driven element, making it look like a 17 meter driven element. He claims that it works well and that he's managed to get 17 and 20 on the Moxon. And I find myself thinking about building this thing. But then I think not, because one of the big virtues of a Moxon is simplicity, right? It's simple. This makes it a lot more complicated, right? complicated to tune, complicated to operate it, complicated over time. If one of these relays starts sticking, then you got to go
Yeah.
up on the roof.
Yeah.
I don't know. My other alternatives are just, spend $400 or $500 and buy a hex beam for 20 and 17, or just build a 17-meter Moxon and put that up there. I don't know. These are the problems that home brewers face. What do you think, Pete?
Well, I think you need to ask a question. Having capability for 17 and 20 would be kind of nice, but would there be one band that you'd favor more than the
Oh
other?
yeah, 17 definitely. Yeah, I know.
So,
That's it. And the 17-meter antenna is significantly smaller than the 20-meter antenna.
yeah, and the other piece of that is when I lived in Northern California, I bought a tri-band vertical antenna, 12 AVQ by High Gain, and that thing worked, and it was right during a sunspot cycle. That thing worked like a bomb. You got it up off the ground.
Yeah.
So you might want to look at just building a vertical for 20.
Yeah.
Don't build a tri-band vertical for 20. Put a little ground plane up there, and then you have both antennas. But getting it elevated makes a big difference.
Yeah.
So I'd look at that, and that's just something you could entirely homebrew without, spending the money that you would buy. I heard a comment the other day. A guy says, "This is wrong. $200 for a dipole that you can build for $10 going to Home Depot."
Yeah, that's it. It is. Hey, we completely forgot about the shameless commerce division here, Pete. And but anyway, this is not really shameless commerce. This is shameless commerce, not at all. This is just talking about a new product, and I have it in my hand here. It's Heathkit, a guide to the amateur radio products by Chuck Penson, WA7ZZE. Chuck is a real authority on Heathkits and on all kinds of technology. He did all kinds of work in the Titan Missile Museum. A really interesting guy. And wow, I mean, I was blown away by his new book. And you guys, especially anybody who's interested in Heathkits, tube type radios, or just radio technology in general, will really enjoy this book because it's beautifully illustrated. He's got all kinds of great diagrams in there, all kinds of lore, Heathkit lore describing the rigs. I learned things about rigs that I've had for 40 or 50 years that I didn't know. Who knew that the HW101, you mentioned this, there was an aftermarket dial for the HW101 that showed the amateur bands and showed information right in the dial. I didn't know. Who knew about that? Who knew that there were two versions of the DX40? I had the DX40. I always thought there was a DX40 and that was it. No, two versions. And you could look at and he described how by checking the RF choke going to the 6146, you could tell which one you have. I've got the newer version. And then this one kind of got to me, and this is along the lines of the criticism that you face, Pete. There's a section in there about the QF1Q multiplier. Yes, I know. I know. I feel terrible. But in it, Chuck notes that the QF1Q multiplier has a really beautiful variable capacitor with a 14-to-1 reduction drive built right in. And I just said, there you go. How could I resist? How could I resist? Anyway, go out, guys, go out and get Chuck's book. It's really well done, beautifully done. It's a beautiful book to have. And you can get it. Just go to WA7ZuluZuluEcho.com. Whiskey Alpha 7 ZuluZuluEcho.com. Okay. Wait, and I think we got to wrap it up. I will take care of the mailbag. Pete, you got to go.
Yeah, I got to go. Hey, listen, guys, tune in 10 and 15 meters. Call CQ. I mean, if there's FT8 signals on there, the band is open.
Words of wisdom from Pete. Pete, you go ahead. I'm going to take care of the mailbag while you're gone.
You bet. Take care.
We'll see you next time. Thanks for getting up so.
Coast.
All right. Thanks a lot, Pete. Thanks for getting up so early.
You bet. Bye-bye.
Bye-bye. All right. The mailbag. Let's see. First of